So, good evening, guys. So, today's topic is NLP basics with Space CY and NLTK. That would consist tokenization, PUS tagging, and lemmatization. So, as natural language processing or NLP is a field at the intersection of computer science, linguistics, and artificial intelligence. So, the goal of NLP is to enable computers to understand, interpret, and generate human language in a valuable way. So, basically, the NLP powers of many of the tools we use every day, like chat box, Google Translate, or voice assistants like Siri, Alexa, that would be mainly sentiment analysis in reviews and even mail spam filters. But as we already know that the language is very much complex and that is full of ambiguity, slang and irregular grammar and evolving text. So that's why we need a step-by-step processing techniques to break it down. So the core building of NLP is that we'll explore three foundational pre-processing tasks which are essential for almost every NLP application. First would be tokenization. Basically, it is breaking the text into smaller pieces that would be words or sentences, giving a just a quick overview of the three foundational pre-processing tasks. Then we will go in depth moving forward. So second is part of speech, that is POS tagging. So basically it is assigning grammatical roles to words, that would be noun, verb, adjective, etc. Third comes the lemmatization. So basically it means that it is reducing the words to the base or dictionary form. For example, running is getting reduced to run. So these are the very much first steps before any complex NLP tasks like sentiment analysis or machine translation or named any entity recognition. So the libraries we'll use in this is Natural Language Toolkit. So basically it is one of the oldest and most comprehensive NLP libraries in Python. It is very much essential for educational purposes and underlying logic as well. And it also comes with datasets, lexical resources like WordNet and Core Tool. So you can think of a NLTK as a teaching lab, great for learning and experimenting with low-level NLP concepts. So for SpaceCY, that is modern industrial strength NLP library, it is very much fast, accurate, and easy to use, and it comes with pre-trained models that supports tagging, parsing, lemmatization, and named entity recognition of the box. So Space CY is a high performance, factory efficient, consistent, and ready for production environment. So why we'll be using both? We'll use both libraries today because NLTK helps you understand what is happening under the hood, and Space CY shows how these tasks are done in real world system that is ready for scaling. So the code for setup is this: pip install NLTK Space CY, that is required, and NLTK setup, that is first is import NLTK, then you need to download the Puncti, that is basically for tokenization. It is required. Without this, tokenization won't be performed. Then you need to download this as well for POS tagging. This is very much important, or without this it won't be working. And WordNet is also required to be downloaded for lemmatization. So these three libraries are required to perform any sort of three pre-processing task. Then Space CY setup is done by like importing Space CY, and this is also required. Both needs to be installed. That's how you will be setting up the space CY library. So, as it is mentioned above, that NLTK helps you understand what is happening under the wood, and Space CY shows how these tasks are done in real world system that is ready for scaling. So, both are important. As Space CY is a high performance factory, efficient, consistent, and ready for production environments, and it is used basically. It comes with already pre-trained models that supports POS tagging, lemmatization, and named entity recognition of the out of the box. So that's why we'll be using both of the libraries. So this is how you will be going to set up. So these three are required. So natural language processing allows computer to understand and process human language. So as we have already explored this part, so now we will get to tokenization. So tokenization is the process of splitting raw text into a smaller units called tokens, that is usually words, subwords, or sentences. So these tokens become the building blocks for all the downstream NLP tasks like part of speech tagging, lemmatization, or named entity recognition. For example, the word tokenization, it splits text into individual words. So I love NLP is there. So every word is getting splitted. As you can see, the sentence is I love NLP, and it is getting splitted into I love NLP. Exclamation mark is also getting separated. So basically the sentence is getting into. And the server tech or tokenization is also there. It splits into smaller units. As you can see this, they are splitting into smaller units as well, and they are used in models like BERT and etc. And so like why does tokenization matter? So words are the smallest meaning elements in text. Machine learning models don't understand them directly. They need numerical or category features based on tokenization. So it impacts accuracy. For example, can't might be split into CA and T because, or like, it cannot be kept as can't based on the tokenization. These are some special cases that we have some limitations for tokenization as well, that they cannot be splitted into the words. So if you imagine reading a paragraph in foreign language with no spaces or punctuation, tokenization is like placing spaces, periods, and commas so you can make some sense to it. So we will be doing this example. As you can see over here, that can't cannot be splitted because this is a limitation for context sensitive analysis. So the sentence is, I can't wait to learn more about NLP with NLTK and Space Y. So everything is splitted, but for this, it cannot be there because there is a limitation to it. So for this example, hello there, how are you doing today? NLP is amazing. So as you can see, it is getting splitted. So now with tokenization with space CY. Again, there is, I can't wait to learn more about NLP with NLTK and space CY. And the tokens, see, over here, like, we cannot again split this into the can't into like this, because space C tokenizations rules are highly customizable using its tokenizers exceptions and customer rule. So basically how space CY's tokenizers works. So it isn't a simple Regis splitter, because it is a rule based pipeline composed of several components. So basically the prefix search is, for example, like characters like dollar, commas, inverted commas. Then the suffix search is for punctuation, exclamation mark, question mark. Third comes the infix search. So basically, it is for characters within words, that is like hyphens, contractions, etc. And fourth are the special case rules that are exceptions for known patterns like don't, can't, US. They cannot be splitted. So these are the special cases, and these are the limitations of this space CY as well. So they cannot be splitted into. So as you can see this, I can't go to USA without my iPhone. So you can see it cannot be splitted. The USA cannot be splitted as well. iPhone cannot be splitted. So can't is broken into CA, can't default behavior for contractions. And USA is not split because space CY has an exception rule to keep it as one taken. So iPhone is also treated as a single token thanks to custom casing rules. And the casing rules are, as you can see, that first one is prefix search, that is for characters like dollar, comma. Second one is suffix search, that is for punctuation, exclamation, question marks, etc. Third is infix search for characters within words, hyphen, contractions. Fourth is special case rules that are exceptions for patterns like don't, iPhone, and US. They are not splitted. So both are rule based, and as you can see that NLTK has a moderate speed, but space CY has a high speed. It does not handles emojis, URLs, etc. It handles somehow, and the custom rules is limited, but space CY is flexible and powerful. So what is POS tagging? So part of speech tagging is the process of assigning a grammatical category like noun, verb, adjective, etc. to each token in a sentence. So this is essential because the same word can have different meanings based on context. So why POS tagging matters? Because it helps us determine the role of each word in a sentence used in tasks like syntax parsing, named entity recognition, question answering, information retrieval, and it helps in lemmatizations, that is, verbs versus nouns require different base forms. So the for the word book, POS part of speech tag is NN, that is noun thing. For book, Again, book VB, that is verb, to reserve. So it depends on the context in which these words are being used. So this book means to reserve something. So that's why it is used for verb. And for verb, VV is used, and for noun, double N is used. Running. This is present participle. So VBG is used. For fast, double J is used because adjective, that is signifying for fast car. And again, here comes the fast. For this, RB is used. In this, adverb is used. It is signifying that for run fast. So that's the reason we are using this tags. And these are the tags what POS tags are. That is part of speech tags are. So basically, these are the tags that are assigned to a word depending upon the context of the sentence in which they are being used. So, noun, that is uh, singular or noun, that can be used for dog and car. Verb, for verb and base form, VB is used. Double J is used for adjective. RB is used for adverb. DT is used for determiner. IN is used for preposition or subconjunction. So here comes what is lemmatization. So lemmatization is the process of reducing a word to its base or dictionary form called the lemma while considering the context and part of speech. Unlike stemming, lemmatization produces real words that are linguistically correct. So why lemmatization is important? Because it is context aware and it uses the POS tag to decide how to reduce the word. And it also provides clean vocabulary. It avoids inflating your model with similar word forms. And it is used in our chatbots, QA systems, and it helps normalize queries and documents. So, what is stemming and what is lemmatization? So basically, stemming just chops off suffixes while lemmatization looks at grammar and meaning. So, for example, you can see running in stemming, it is only like it just chops off the suffixes. As you can see, for running, it is only run, double N is there. But for lemmatization, it looks at grammar and meaning. So for this case, it is RUN, only single N is there. So it is signifying a meaning. For better, the word is better, and for stemming, it remains the better only. But for lemmatization, as it reduces, it becomes good. For studies, as you can see, for stemming, it becomes STUDI, but for in lemmatization, it becomes study. So basically, it is reducing the word in a way that it assigns a meaning. And for MR, in stemming, it remains MR only, but in lemmatization, it remains as B. So you can think of lemmatization like finding a person's official name in a government database. For example, Bob, Robert, and Robbie, all mapped to Robert. When stemming just chops names. That is, Robbie is Rob. So basically, in stemming, the real words are not used, And but in the case of lemmatization, the real words are used. Is it context aware? Stemming is not context aware, but lemmatization is context aware on the other hand. Oh, it is, but yes, stemming is fast. While we look at lemmatization, it is slow, but it is like more accurate than stemming.
Ma'am, can you please share the PPT of today's lecture?
Yes, and last lecture also I will share it. I'm so sorry. I think it did not get shared, right? Yeah.
Okay,
So
ma'am. Okay, ma'am.
sure. As you can see, Kant is getting splitted, but USA is not getting splitted. iPhone is also not getting splitted. So there is a case rule. So basically, there is a case rule. So the prefix search is first for characters, that is dollar, comma, inverted commas, etc. Second is suffix search, that is for punctuation, exclamation mark, question mark, etc. Third is infix search, that is for characters within the words, for example, hyphens, contractions, etc. And fourth comes the special rules that are exceptions for patterns like don't, iPhone, and US. And in this example, you can see this is the sentence, and you can see can't is getting split, USA is not getting split, iPhone is also not getting split. These so this is a special case. In this, POS is used, that is part of speech with NLTK. So the text is the quick brown fox jumps over the lazy dog. So POS basically it assigns, as you can see this, it is getting split as well, and the is getting assigned to determiners, and the short form of determiners is DT. Quick is getting assigned to adjective, and the POS tag for adjective is double J. Brown is also an adjective, so it is getting assigned to JJ, that is POS tag. Fox is a noun, so it is getting assigned to NN. Over is ADP, and it is assigned to IN. So IN is basically preposition or subconjunction. So the is getting assigned to det, that is determinants DT. Lazy is getting assigned to adjective, that is double J again. So dog is also getting assigned to noun, that is double N. So as you can see, these and for punctuation it is blank. So you can go through the code. Then again we have one more example for today. So basically, why POS tagging matters because it helps us determine the role of each word in a sentence, and it is used in tasks like syntax parsing, named entity recognition, question answering, and information retrieval is also there, and it also helps in lemmatizations. That is, verbs versus noun require different base forms. So that is why it is used. So, in this, the required sources would be PUNKT, that is required for tokenization. WordNet averaged perception tracker is also required, that is for peers tagging like noun, verb, etc. WordNet is also required for lemmatization using WordNet lemmatizer. So, as you can see, this. So basically, this converts the POS tags from NLTK tree bank style to WordNet format, which is required by WordNet lemmatizers. Why it is needed? Because NLTK and WordNet use different POS tag conventions. Like for tree banks, that J is for adjective, V is for verb, N is for noun, R is for adverb. That is like the tree bank that starts with, because NLTK and WordNet use different POS tag conventions. So tokenization and tag POS. So you can see the tokens. J is for adjective, V is for verb, N is for noun, and R is for adverb, and default to noun. So and and tag POS is there. So for input, we are taking his studies better and is running quickly. So tokenized will be he will be separated, studies will be separated, better and is running and quickly. All of this will be separated by a comma, and even a full stop will be separated. And the studies will be VVZ, and better would be RBR, etc. For this. So this will be using, like, it will use the correct POS with each word. So basically it is going to perform true lemmatization. And as you can see, this was tokenized. As I told, this even the full stop will be inside the inverted commas. So as you can see, for he remains the he. Studies get lemmatized to study. Studies got lemmatized to study. Better got lemmatized to well. And remains the same. Is going to be T. Running got lemmatized to run. Quickly remains the same. So these all packages are required to perform all this. So please go through the code. So why, like as you know that lemmatization is the process of reducing a word to its base or text, like base or dictionary form, like called the lemma, while considering the context and part of speech. Unlike stemming, lemmatization produces real words that are linguistically correct. So basically, it is context aware also, and it provides a clean vocabulary. It avoids inflating a model with similar word forms.
Ma'am, I have a question.
Yes, please. Yes, please go ahead.
Uh, uh, the normal POS tags means the words in short forms like NN, JJ, and the word net POS tags refer to the actual word. Like NN stands for noun, and ADJ stands it's like AD for adverb, and so on. So on. Is it right?
Yes, it is right. Basically, the POS tags are like it is getting assigned to, like, for example, a dog, right? It is a noun. So NN is the POS tag for noun. So
Yeah.
say yeah. So on. The categories are diversified, and there are various POS tags for different things, verbs, adjectives, adverb as well. So basically, they are getting assigned to the POS tags depending on the sentence and the words present there.
Yeah. Okay, ma'am.
Yes. So, quick discussion like what is the difference between stemming and lemmatization? So, basically, stemming crudely chops up word suffixes to reduce word its root form. So, for example, running would be run and studies will be study. But in lemmatization, it returns a dictionary base form of the word. For example, running would be run, and better would be good. So it considers the part of speech. Lemmatization is more accurate and context aware, and stemming is faster but less meaningful. It does not provide any meaning, it just chops off the suffixes that are provided. So, so why is POS, that is part of speech, is important in lemmatization? Because the lem of a word depends on its role in a sentence. So, booking as a noun, it stays booking only. But booking as a verb becomes book. This helps lemmatization make the correct transformation based on the usage text. So, as explained above, so it is a process of reducing a word to its base and dictionary form called the lemma. So, while considering the context and part of speech, unlike stemming, lemmatization produces real words that are linguistically correct. And as you can see that for POS, it helps us determine the role of each word in a sentence. It depends. Like for book, it can be noun also, and book can mean also a verb that is to reserve. So it depends upon the word that is present and like what it is meaning. So accordingly, it is getting in like assigned for POS tags. So PS helps lemmatizers make the correct transformation based on usage text. So it can change the meaning of a sentence. So for this, the answer is not typically, but it can simplify or normalize words, which may slightly alter tone or nuances. So, for example, better would become good. R can could become B. So, in practice, it means to like it means to preserve core meaning while making words easier for computer to analyze. So why is getting converted to be? Because is a form of verb and to be is the base form. So why is apple tagged as okay? That is the other example. I will share you the document, then you can do it is provided over there. So what is the difference between POS and lemma? So PS describes what the word is doing, and lemma is a dictionary form. So, do all NLP pipelines require POS and lemmatization? Not always, but they improve accuracy in many tasks, search, chatbot, translation, etc. So, can Space handle languages other than English? Because these models are available for German, French, Chinese, etc. Both punctuation and emojis. Spacey-wise treats them as individual tokens, and that are useful for social media analysis as well. So as you can reinforce the flow, that is raw text get to tokenization, then POS tagging happens, then lemmatization happens, and there comes the clean data. So basically, the tokenization, then keyword matching, then POS means that intent analysis, grammar correction, lemmatization means search engine language models. So reinforce the flow again. Raw text means that it is getting converted to tokenization. Then since it is getting split, then the POS tagging happens. That is part of speech tagging. Then the lemmatization happens. Then here comes the clean data. So this is the flow. So I will be sharing today and last session's file as well, along with the files of example as well. I will make sure that it reaches you. So that's it for today.
Thank you, ma'am.
Okay.
Ma'am, what is the Spacey? Is it a pre-trained model or just a library present in NLTK?
So it is a library. So it comes with pre-trained model as well. So it is more beneficious than NLTK. So it is just a library.
Okay, ma'am.
Okay. Okay, so guys, this is it for today. So we'll be wrapping up for today.
Yeah, madam.
Thank you, ma'am.
Yes.
Madam, can you provide any
Thank
LMS
you,
for
ma'am.
data science and human
Sorry.
LMS,
Can you come
madam?
again?
If you don't, uh, will you prefer me any LMS for some Infotact?
Okay, I'll get back to you regarding this. You need an
Okay.
LMS, right?
Yeah, yes,
Okay.
madam.
Yeah, I'll get back to you regarding it.
Okay.
Okay.